So we are trying to do today here is give a basic introduction to the services available in Microsoft Azure and what you can do with it. So without further ado, let's jump right in. Let me share the screen and I hope you can see it.
Yes.
Yes, okay. So as per any other resource in Microsoft Azure, you have to have a resource group first. So I have a small presentation also. Don't worry, this is not going to be a slide show. It is going to be some. There will be some demo, and if you have any questions, you can ask them as well. So let's move on. I am Nishan Wickramarathna from Azure Trintech here at 99X Technology. So as I mentioned, the logical workspace that we have in Azure Machine Learning Service contains these resources, which are computes, notebooks, pipelines, data, experiments, and models like so. But hopefully, I think some of you may have come across these concepts of machine learning where to give you a basic introduction, where we use some data sets or predefined values to come up with a prediction or a classification, right? So we will do some examples as well, then you will get to know what we are trying to do. So when it comes to machine learning, there are many things that you can focus on, like forecasting, prediction, classification, etc. But each and every one of those things can be achieved using Azure machine learning. So apart from the workspace, we have some other storage accounts, application inside keywords as well, because you might have guessed these compute resources are actually virtual machines, and to maintain the data, and if you have a data set that you want to upload, then obviously that will be the case for us. So you have to have the storage account, because this data will be stored in a Azure blob account, I mean blob storage. So yes, we will move on. So yes, before going into that, let me show you the workspace that I have. So here I have a resource group called Azure ML demo. So you can see inside the Azure ML demo, it is just a normal resource group. There's nothing fancy about it. It is not a machine learning specific resource group. It's just a resource group. And here what you can do is you can create a workspace. To create a workspace, you can go to the add resource and then search for machine learning. When you search for machine learning, you will get this. So if you create this resource, all those things that you saw in that resource group that I showed you will be created automatically. Um, Not these infer clusters. I mean, these are AKS services, Azure Kubernetes cluster. Not this, but everything else, like this key vault and storage account and app insights together with this workspace will be created. Once you have this workspace like this, there is no specific things that you can configure here. What you have to do is launch Studio from this link. Once you have launched Studio, you will come to this view, which says Microsoft Azure Machine Learning, and it says that there are different groupings here as well, which are authoring assets and managing. So let me first of all give you an introduction about these compute instances. There are many. I mean, there are four compute instances, which are compute instances, compute clusters, inference clusters, and attached compute. What are those? These are basically some machine learning. I mean, virtual machines. So to create a machine learning model, or to upload data, or to do any other kind of a work, you have to have a compute instance created before you start working on training your models and etc. So to do that, you have to click on this new button, and then you will be having the opportunity to select what are the things that you want to, I mean, configure. As a example, you can configure the instance type. So for an example, we have used here this one, a standard DS3v2. Or you can go for a lower tier as well, but obviously you have to understand with these specifications your performance will be affected, because if you go for a lower RAM instance, then there will be some overhead time for your machine learning model to be trained and configured, right? And I hope you understood that. So you can either choose CPU or GPU. After selecting what you want to do, you can create it. This will be created. So first of all, let me just show you, go back and show you what are the things that are available in this authoring section. So for the authoring section, we have notebooks, automated ML, and the designer. So for authoring, what these notebooks are, which are just a way to run your code. If you are familiar with machine learning, you know that Jupyter notebooks and Google Colab. So these notebooks is a similar instance. It just creates Jupyter notebooks inside of that compute instance that we have created. There's nothing fancy about it. It's just a Jupyter notebooks. I mean, the machine learning framework will be installed into your instance automatically, and then you can use notebooks as it is. And this automated ML is a service that by looking at the data set that you are having, Azure Machine Learning Service will determine what is the best machine learning model to analyze or they predict or classify your data. So if you are coming from a non-machine learning background, like if you don't understand these concepts of machine learning or how to train a model, how to do pre-processing on data sets. If you don't understand that, the best option is automated ML. You just have to upload your data set and it will automatically run multiple models on top of that data set, and Microsoft Azure ML service will tell you, okay, this will be the ideal model for your data set. And then afterwards you can deploy that model as a web service or something else. We will come to that. And designer is the thing that you can see here, which is again for the previous people who are having less experience on Python or scripting in R languages, because these is, as you can see, has some drag and drop blocks, which is similar to the Azure Machine Learning Studio Classic version that we had earlier, like 5 or 4 years back. If you are following up with these things, you might have came across this Azure Machine Learning Studio, which is now deprecated, but it still works. But this designer is more advanced version of that. And you can see, you can create this. There are some steps involved when you are trying to create a machine learning model. So like splitting data, I mean filtering, and then you have to attach the model. As an example here, you can see the model is 2-class boosted decision tree, and you can do the different models and you can plug them in and you can run the application. Again, what I have to tell you is, if your compute instance is advanced enough, this machine training process will be completed within a short period of time. But if you use the resources that I have used for this demonstration, sorry, it will take like 30 minutes or so to complete the training, right? So yes, and how this authoring comes together with those compute instances. I showed you 4 compute instances. Um, Mainly, sorry about this. Okay. All right. Can't seem to move it. Doesn't matter. You understand. The first one is compute clusters, and then we had compute instances, and then we had inference clusters here. right? So we have attached compute as well. I didn't want to explain that one because it is just as the name suggests, it is just a way of attaching your own virtual machines to Azure Machine Learning Studio. But I don't think we have virtual machines lying around here and there to plug them in and do machine learning models. I mean, for me that is not the case. So what you have to do is create a compute instance, compute cluster or inference cluster, depending on the thing that you have to do. So to create a notebook, basically you have to have a compute instance, and to use the designer you have to have a compute cluster. And to create after creating the designed I mean the machine learning model, you obviously we have to deploy it as a web service. So to deploy that also we are using inference clusters, which is a Kubernetes service, AKS, Azure Kubernetes service. So after creating the machine learning model, your web service will be deployed into a AKS cluster, right? So these are the how they are linked together. As I mentioned here, compute clusters, we need them for the designer and automated ML, and compute instances are for notebooks, and inference clusters are for deploying it as a web service. So let me show you how to create compute clusters as well. There are different parameters to set in some cases. So here you can see you can have a priority dedicated to a low priority. If it is low priority, then you can reduce your cost. If it is dedicated, obviously your cost will be increased. So as per the previous compute instances in instance creating, here also you can decide which one to use. This is the default selected one, but I suggest that if you want to explore the service, you just go for a instance like this standard DS1 V2, because it incurs less amount of cost. Yes, and if you go to create an inference cluster, and then you have to create new one. Then you have to select the region as well for inference clusters, as because they are running on Kubernetes. And if you want to create a new instance, what you will get is again this kind of a selection to decide which one to use. Here there is some level of further customizations. So you can see here you can decide number of nodes and compute name as well. And if you want to have SSL configured, you can configure that as well. There's that, and it is not very hard to do this, but it will take some time to deploy. That is why I have already deployed these three instances. One other thing I forgot to mention is that when you go to create this compute cluster, so don't worry if you are failing to link these services with the compute instances. You will get to know once you are trying to create these machine learning models. Azure ML service will tell you need to have a compute instance if you are going to create a notebook. Then you can easily create that. That doesn't matter. And like here, if you go to the next, you can decide whether to use minimum number of nodes as 0 or 1. Like if you decide to go with minimum number of nodes as 0, what will happen is there will be no machine learning, I mean virtual machine configured at the beginning. Once you try to run your machine learning model or the designer, it will automatically it will automatically allocate virtual machine for you, and it will start machine learning model inside that. So the disadvantage of this approach is that it will take time, because this allocating nodes takes time. You can do that and you can try it out. You will see for yourself that this will take time. That is the thing that I mentioned here. It will go from 0 to 1, uh, 0, and then it will go to for the preparing stage, and it will go for the running stage. Usually this process takes like 20 or 30 minutes, depending on depending on the configuration you are having, right? And that's it. There is no such hard steps to configure these three instances, right? And we'll jump on to notebooks. If you go to notebooks, you will, if you have created this the first one, compute instance, then you will get your own users folder as in Windows operating system that we are having, and then you can upload your data sets or any other notebooks that you are having here using these icons. But what I have experienced is that creating a notebook in this view is not going to work all the time. A workaround is, if you really want to, start with notebooks. If you don't worry if you don't know what our notebooks is. I will just explain this one. And so what you can do is, if you go to compute instance and if you click on the created resource, you will be redirected to this view. In here, you will see there are some application URI saying Jupyter Lab, Jupyter RStudio. What you can do is click on this Jupyter link. It will open up the Jupyter notebooks inside of our compute instance, like so. So I hope if you are a machine learning enthusiast, you are familiar with this view. Then what you can do is go to the place where you have stored it, or you can upload your data sets or files from this links as well. It's just a matter of uploading and then running your code here. So I have an example. So the example that has been displayed here, I have a data set with daily website visitors, and then I have the notebook, right? So this is it. We have different data here. Let me just, before going into that, let me just show you again how to upload these data sets as well, because there could be some sorry, there could be some configuration issues here as well, because to upload the data set, you have to go to this assets group and click on data sets. Or usually our data sets are CSV files, but you can have any kind of a data set as long as you know how to manipulate them. So I have currently two data sets. I will upload another one to show you how to configure this, how the configuration window is displayed. So here what you can do is give a name for it. I will just give something like ABC. Doesn't matter. You can decide what is the type of the data set. Usually they are tabular. And then inside the data store, you can browse for your file and it will be uploaded, right? And in the settings, what so it is uploading the data set. In the settings, what you see here is usually in CSV files, the first row is our column headers. So we have to tell that Azure Machine Learning that the first row contains our headers, like custom ID, gender, and that. So we can configure that here under column headers, saying use headers from the first file. Obviously, there could be many files uploaded. So we are taking the headers from the first file, the only file we are having. So now it is configured properly. And again, if you go to like schema, you can decide what are the data types of these values. Like for gender, we have these values, female, male, and Asian machine learning has detected another male. Doesn't matter. So type is string, but in numbers you can see there are these comma separated numbers. Um, Sorry, so the decimal values. So obviously we can use decimal, but in some cases you might see these numbers are comma separated. Usually when we write like currency and those things, we tend to separate the numbers into three pairs of groups using commas. If that is the case, this decimal or integer will not work. You have to use string, and then what you have to do is in the code, in your Python code, you have to configure that to be integer. If that is the case, that is very easy to do. I will show you that I had to do that once. So that is how you are uploading a dataset. Once you have uploaded a dataset, and you can use it anywhere. But for notebooks, that is not the case. For notebooks, you have to upload it from here, or you have to go to Jupyter Notebooks instance, and then you have to upload it from this place, right? And so here, what we have done is we have created the printed the first 5 rows. You can see these visits. They have this comma in the middle, 1558, which is an integer value, but Python detects this as a string, most probably because what we are trying to do here is we are trying to forecast the daily visitors for this website. So we are using a library called Prophet. Uh, this is not related to Azure Machine Learning, but I just want to tell you that everything that you can do on your local machine can be done here as well, right? And then using Prophet, what we do is we are creating the time series that we want to do, that we want to forecast, which is the uh, date column from this dataset, and then we have the first time visits column from this dataset, and then we create this dataset. And then what I have done here is the is where I just converted that comma separated numbers into integer, because this FB propert, which is obviously a library from Facebook, doesn't allow you to have a y variable as a string. It has to be integer. So that is why that is what this line is doing. It replaces the comma and can convert that as a string. And then what we do is we forecast the prediction for 365 days, which is an year, 1 year. So these things are machine learning related. You have to create an instance from the property, and then you have to fit it to train the model. Once you fit the data set that or the data frame that we have found here, your instance of FB property, which is the M, it will be able to forecast for whichever time frame that you are giving it. So for me, I will do it for 365 periods. So this 365 coming from this calculation, you have to uh, multiply the number of years by the number of days. If you want to do it for like 2 years, then you have to multiply 365 into 2 and then use that value as periods, right? And after that, you can easily get the forecasted value, and then you have this upper limit and the lower limit where the machine learning model assumes that this value could go, right? So this is a simple plot. These things in points in black shows you that the real data, and there you might see that there is a region here that you don't see black data points, which are the forecasted value. So what we can do is create an interactive graph. There's a graphing library called Plotly, and using Plotly, we can do what we can do is we can create an interactive graph. In an interactive graph, you can span and zoom into these things. As an example, if I just take this portion in time, you can see the predicted values. In black, you can see the actual values, and in the blue, you can see the predicted values. Like so, you can forecast. This is the forecasting example. So anything, any classification, binary classification can be done here. It doesn't matter what the thing that you want to do, it works as a normal computer. So if because we are using this compute instance, right? That is notebooks. So let let's just go into this designer, which is the most important part for the people who are having like less coding experience in machine learning. You can use the designer, and at the last I will come into this automated ML, right? If you go to the designer, what you can do is you can use existing sample here. So for an example, you have this a binary classification for customer relationship predictions, and here you can see binary classification for custom Python script, right? So it is good that I saw it, because one thing that I have to highlight is if you the designer doesn't have the functionality that you want to do, you can always import Python code as well into the designer. Not just drag and drop modules. They have we can use Python code as well to do some manipulations inside the designer. So there's an example for that. You can create these instances and try to run it. So for this demo, we will try to go with this one, binary classification with feature selection, because I want to show you that this selecting features, how to select features as well, because there could be some people having some less experience on Python or related language in machine learning. But what we have to understand is you have to have some basic understanding on how to create machine learning models, because these pre-processing steps and these concepts like splitting data and then converting these data types, you have to know that that has to be done before you train a model. So to do that, I would suggest to do some basic machine learning course. Or what you can do is you can follow the Microsoft exam for this machine learning service, which is DP100. So it doesn't matter you do the exam or not. There are some there are some learning paths here. You can try to complete these exercises and get an understanding on how to build these machine learning models on Python. So that is it. It doesn't matter if you don't know these things or not. Uh, it is just a matter of it has a smaller learning curve. You can do it like in one day, if you ask for my opinion. So here what you can see is this is binary classification, the experiment that I have created earlier before we start the session. But if you want to create a binary classification, what it will show you is this. You will have this view, and this is the designer that I have talked to you about. You can switch the model if you don't like two class boosted decision tree. So if you don't know what are the models available, you can go to this pan right here, and then you can select on the machine learning algorithms that you want to use. Here you can see there are different algorithms. So for depending on the problem that you are having, you have to select what is the model that you have to use. So to do that, you have to have some kind of a basic understanding on these models. But again, what I have to tell you is it is just a matter of reading about it 10 to 15 minutes, and then you can decide on what to do. You can just swap them in and out, and then you can decide on which machine learning model to use. Right. So as per the example here, so what we are trying to do is we are trying to create a classification model. So if you let me just go to the one I have submitted. So you can see there's a submit button here. To submit it, you have to configure the compute target also, so which is the target that I have created. So if you click on select compute target, you can use an existing one, or you can create a new one. So this is the compute cluster that we have created. So you can select that one and submit the experiment. When you submit it, you should be able to create an experiment. So these experiments, as the name suggests, can have different versions. So in the first run, you should be you will be using two class boosted decision tree, and maybe in the second run you could be using some other experiment, some other model, right? So in that case, you can change the experiment as well if you are submitting it. So once you have run and created this experiment, all those experiments will live in this area where you can see it says experiments, right? So for when you start it, you don't see anything in a way. You can't actually you can't even view this data. You have to run it once, and then you have to only then you will be able to view the data as well. You can so that you saw that I have uploaded two data sets. Those data sets will be here in the dataset drop down. So you can drag them in, and then you can configure uh, to use that data set instead of this one. You can sorry, you can create delete it, and then you have to plug this, and then in splitting what we are doing is we are splitting it into training data set and the testing data set. Based on the training data set, the machine learning model will be trained, and then the trained model will use the testing data set to evaluate itself. That is how the machine learning is working. So here you can see we are splitting it 50-50. So 50% of the data will be taken as the training data, and 50% will be taken as uh, testing data, right? So you can create a random seed and then do different configurations there, but that doesn't matter. Usually what we do is we use 75% as training and 25 as testing. It doesn't matter, it's up to you. And then you can decide which uh, features to be used. So they have this filter based feature selection. So usually what we do is when you train a machine learning model, you use your intuition, and then you try to come up with what are the features that can be that can contribute to this outcome. I'd say, for an example, if you are trying to predict the heart failures, then the weight of the person could be an important factor, and the age of the person could be an important factor. But the person where the person is living is not going to be an important factor. Like there could be some relationships, but usually we don't think that the town that they are living here could be contributing to heart disease, right? So likewise you would try to get that different features, and then you try to train your model and use different combinations, and then you apply different transformations onto that data to come up with a good accuracy model. But with this filter based feature selection, which use this chi-squared method, what they can do is they can select five features based on this method called chi-squared. I'm not going to deep dive into that, but you can change the method into Pearson correlation as well. So it will only use five features from this data set, and then it will do the model, I mean, train the model. And then if you are not happy with it, you can run it again. Like so, you can decide what to use and where to use it. So you can see we have a train model. To train the model, we are getting the input from the selected features, and then we are getting an input from the model that we have chosen, right? And then what we do is we score the model, and then we evaluate it, and that part is the training part. And for the testing also, we use the columns to transform, and then we apply the transformation. Like there could be some transformations applied, so you can apply those things. Here the transformation as an example, a transformation can be like this. So the transformation that you saw in my notebook is one transformation. So here you saw that I had to change the data type of this variable first time visits into integer. So this could be a transformation. So this transformation may not be coming in the designer. So in that case, what you can do is you can run a Python script inside the um, designer, and then you can uh, run some specific uh, Python code as well. Here you can see in the Python language, you have this execute Python script and create Python model blocks as well, right? So that is it. So this one here, which has been completed, you can see it has changed its color to green, and it has this label called green. I mean, label called completed. And here you can visualize the data. I think we will see. Yes, so like so you can visualize the data set, and you can see there are some integer values and string values. But when you do it if you are trying to develop a machine learning model, you have to convert all these string values into integers as well. If you know if you know how to configure these things, then you will have no problem on doing that. But that should be the case. So if you are really interested about machine learning and then all those things, then I suggest you to go and learn about it, about the things that I have mentioned, like how to do transformations and how to manipulate these variables that are string variables. So as for an example, you can see this education column has bachelor's, HS grad, 11th, bachelor's, master's, like so. So what you can do is create this, assign number one to string bachelor and assign number two to HS grad, like so you can convert this education column into integers. Otherwise, what you can do is you can take the probability of how many bachelor's degree holders are in this data set, and you can assign the probability of the bachelor's degree holders into this string value without using number 1, 2, 3, 4. That should be a more specific, I mean, more accurate representation of the word bachelor's, right? Other than using 1, 2, 3, 4, assigning the probability of bachelor degree holders to this cell is accurate representation of the word bachelor's. So like so you have to go through these things, and you have to do that. But you can do that using a Python script also, but also you can do this using this apply transformation as well. After this model has been scored, what you can do is you can visualize the uh, model as well. Let me check. Yes. Yes. So in the evaluate model block, you will have this different charts and matrices, uh, how the model has been created, and what are the different ROC curves and precision recall curve. Like so, these curves are coming in handy if you want to decide which model to use. And if you go for a table, then you can see these kind of things like recall, precision, and like so, right? So that is the designer. After you have designed and run the model, and if you are happy with what you see in the evaluation block, what you can do is create inference pipeline. Like there's this new concept called ML ops, which uses machine learning and DevOps, machine learning and DevOps together. So there's nothing fancy to configure here in the Azure Machine Learning Studio. So that is why they say this inference is a pipeline. So I just mentioned you that otherwise you will be confused that this is a uh, DevOps pipeline. No, this is not a DevOps pipeline, but this is a way of configuring a machine learning model to take inputs from some other third party, maybe web services or front end applications, and then decide on a output prediction or classification. So what we can do is after this all these blocks are completed, you can do is create an inference pipeline. Once you created it, you will see there are some changes happened to your designer. We don't see those other uh, unnecessary blocks here, like the machine learning model, like the two class boosted decision tree is no longer here, and other things like splitting data, those things are not here. What we have is we have a web service input and a web service output. So these web services will be deployed to the Azure Kubernetes clusters, as I mentioned in the compute section. Right? We created it. So what we can do is we can submit it, and then we can again, as I told you earlier, we have to select an experiment. So I will create a new experiment. I will say this is final, and you can see our cluster is coming in as computer cluster AML, the one I have created, and you can submit it. Right. Once you have submitted it, it will run again, and it will um, uh, deploy these web services into the AKS. Then they will give you an endpoint to call these web services to get to give data input and to get the output as well. You can see we have to run all these blocks to for it to be deployed. It will take like 5 minutes or so to do this. While that is happening, let me show you some documentation on regarding this deployment. So so here what I have to tell you is we can deploy Azure Compute instances as ARM templates as well. So we have this uh, machine learning machine learning advanced ARM template. You can use or refer that to if you want to deploy your compute clusters and use that as infrastructure. And one other thing I have to tell you is this: there are this feature called Azure Cognitive Services as well. They are not like training machine learning models, so like that. They are just API endpoints that developers can use out of the box to do some analysis. Like as an example, if you go down here, you have this decision, language, speech, vision, web search, like so. So as an example, if I go to the vision and if I go to face, if you want to detect faces on an application, you can create this cognitive services instant, and they will give you an endpoint. So you can call that endpoint with your image, and it will give you this JSON response to giving a rectangle where the face is located and whether it is smiling or not. If you There are two models for that, and so they are in the decision detection one model. You have that hair color and other like smile, head pose, gender, other those thing kind of classifications. These are like really cheap. It doesn't actually incur a lot. You can use easily use free services if your application is small. Let me go to the pricing. So you can see the this free container contains like 20 transactions per minute, and you can have 30,000 transactions per month. So that is like if you go for a paid, I mean standard instance also, it is like 0 to 1 million transactions. It is like $1 per 1,000 transactions. So these kind of APIs are available. These are called Azure Cognitive Services. If you are interested in doing that and not using machine learning to train and build everything from scratch, you can use Azure Cognitive Services. And another thing that Microsoft has is this Azure Python SDK. There's a SDK for Python. Where is it? Yes. So you can, as if you have installed Azure Python SDK, what you can do is you can there onward import HTML core into your notebooks, and then you can create workspaces and create experiments using Python language itself without going into the designer and all those things. If you want to utilize the services that are given by Azure Machine Learning services on the uh, Jupyter notebooks, you can do that as well. So that's that. But here in this demonstration or the discussion, what we are trying to tell you is this new features that they are having, right? You can see some of the modules are completed and some are queued and some are running. Right, while that is running, let me just show you this automated ML as well. In the automated ML, what we can do is, as I explained, you can just upload the data set, and then you can tell Azure to come up with the best model that they think that is best suited for it. So let me just create a new AutoML run. So like if you don't have any experience on deciding which model to use in which scenario, you can upload your data set. And so I showed you where to upload the data sets. It is here, right? And if you have uploaded it, you can select it from here. Let me take this one, which is a customer churn data set. So if I click on next, then what you can do is you can again select the create experiment again, and you can decide which column that we are going to predict. We are going to predict this churn column, and then again you have to specify the compute cluster that you want to run this experiment. So this is the compute cluster that we have created, or you can create a new compute cluster. Sorry, and you can click on next. And so you can decide which model sets that you want to use. So churn is usually a classification problem, whether like it is a yes or no problem, right? Whether the customer is going to leave the service, or whether customer is going to stay on the service. So in those kind of problems, we can use classification. If you want to predict a continuous numeric values, which are like salaries, like the populations, and like these the values that are having these decimal points with associated with them, we can use regression. So they have selected classification because I have selected that our target column is going to be churn. So they analyzed the data set and decided on classification. If your target column has continuous numeric values, then it will be selected as regression, or time series forecasting as well. Time series forecasting is what I did in this notebook, where you have as one variable you have the date, and as the another variable you have some numerical value. If your data set looks like this, then definitely you have to go with time series forecasting. So classification, I don't want to enable deep learning. If you want to, you can do that. Then you have to you click on finish. So it is not yet started. Once it is started, it will go ahead and um, tell you, okay, we used this model and that model resulted in this much of accuracy. And then again, it will select another model, and then it will show you that, okay, the second model resulted in this much of accuracy. Then by looking at it, you can decide which model to use. At the end, they will tell you uh, what model is the best model. Yes, so let me just go on to this. If this is taking like time, I had some screenshots that I can show you how to. Let me here. You can see those things that I have showed you. It doesn't. So yes, after that we deployed that inference cluster. We deployed our machine learning web services into inference clusters. Once that is done, you will get this success message, and you can then click on this deploy button to deploy it. Right? We will see if time persists, whether we can see it or not. It doesn't matter. Then we get this consume REST endpoint as well, and with some API keys. So you can use this endpoint and these keys to call this web service and get a prediction in real time, right? And so this is the calling part, which I used using Swagger. Let's check whether this has finished. Looks like it has. Right. So now we are good to go and deploy this inference cluster. Then you can use a name for this endpoint. Let's say sample. It doesn't matter, just a readable name should be fine. I will say like this, and you can give it a description, and then you can click on Azure Kubernetes service or Azure container instance. And then you can select the inference cluster that we have created when we are creating those compute resources, right? And in the advanced column, you have like timeouts to decide, specify a number of replicas like so, but I'm not going to do that because it will take some time and incur cost, and so that is why I'm just leaving it as that, so we can then deploy it. We don't have any models yet. It is still running. It is, as I said, it will take some time to do that. The longest time that I have seen in this Azure Machine Learning services is consumed by this automated ML, because it swaps these machine learning models and try to come up with the best score, best accuracy. So while this is happening, if you have any questions, you can ask them, because we are like nearly running out of time. If you have any questions, you can ask them. So currently we are at this endpoint creation step. Once it is done, it will say that the deployment is successful. Then it works as a usual API, and then you can call it with the keys. So you can also another thing that you can notice is we had that training pipeline here, and once we submitted it and we said that we want to create an inference pipeline, it created another tab. So in this tab we have our inference type pipeline. In this tab we have our classification training pipeline. If you want to do an update here, you can do that, and then you can click on update inference pipeline and you can update it again. Okay, it's let's check on this pipelines or the endpoints. If it is deployed successfully, it should show up in this endpoint. Right, we have the deployment, and if you go into it, and if you go into this consume tab, you will get this REST endpoint and this key also. So what you can do is you can use you can get the Swagger JSON file from this endpoint as well. So it resides on. Let me check on the documentation. I can't. Here you can see the Swagger URI is without this port, and you had to have this Swagger JSON at the end. So if I copy this and sorry, JSON Swagger JSON, and if I remove this port, all right, it is. I think it is still deploying. These are the pipeline runs that we had. You can see we don't have this SSL certificate because we didn't configure it to have SSL certificate. If you want to configure it to have SSL certificates, as I mentioned earlier, if when you're creating this inference cluster, you can change it to have SSL configured with it. It really doesn't matter, but if you really want to secure it, it should be the case. I think it is still deploying. but you get the idea. Like you have you when once you have has the deployment, you can get the Swagger JSON, and then you can use Swagger to call the API and get input like this. You can authorize it. I think you are familiar with Swagger, so you can authorize it using that keys that has been given here in this consume tab in the service endpoint service. And then what you can do is you can authorize it, then you can have this endpoint called and get the prediction. You have to pass this all the other features that we have in the data set as the parameters as a JSON object. Then what you can do is you will get the response as 200 with the prediction label. So you can see here uh, you can see the scored labels are true. This is the prediction. So you saw that we had like two outputs because for the training pipeline and the classification, I mean the testing pipeline. So for those two web services, you will get the output. So that is it for the demonstration. If you have any questions, you can ask. If not, I think we can conclude the session. Go ahead and try to create. Okay, now we are having the Swagger JSON. So what you can do is you can copy it and go to Swagger IO. Okay, I messed it up. Right. See, you can have this kind of endpoints, and then you can authorize it using the key value that we have here. Yes. Once that is done, what you can do is you can like get this, not that one, right? You have to use this one. You have to send this as um, JSON object. So you make sure you to remove this income parameter from the JSON object, because what we want to do is to predict this value. So you are not going to send that into the API. Let's try it out. Hopefully it will work. We just want to do it for one. We will remove all these other parameter sets. And if you execute it, let's change few things. I mean, you get the idea, right? And you can execute it. So we will get 200, and with that we will get the scored label as well. Right. Yes, that is it, guys. Thank you.